Now see, this is exercise 4.1, question number 18. In this case, he said that 1 plus 2 plus 3 plus so on so plus n is less than 1 upon 8 into 2n plus 1 ka whole square. So this inequality we have to prove here. Once again, we have to apply the 3 steps. Step number 1, as you know, that is a put n is equal to 1. So when n is equal to 1, in this case 1 is less than 1 upon 8 into 2 into 1 plus 1 ka whole square, means when we solve this one, it gives 1 by 8 into 2 plus 1, that's a 3, 3 ka square, that's a 9. So ultimately it is equal to 9 by 8, and 9 by 8 is equal to 1 point something. So that means clearly 1 is less than 1 point something, that means 9 by 8. So clearly result is true. Result is true for n is equal to 1. So when n is equal to 1, in this case you see that your inequality will be hold. That means this concept is a true. Okay, let us check again. When assume that step number 2, you know, assume that result is true for n is equal to k, means 1 plus 2 plus 3 and so this is a k is less than 1 upon 8 into 2k plus 1 whole square. So let us assume that this result is a true. Okay, step number 3. Now we shall prove that result is true for n is equal to k plus 1, means when n is replaced by k plus 1, let us see what's happened. It's a 1 plus 2 plus 3 and so n is replaced by k plus 1, so it's a k plus 1 is less than 1 upon 8 into 2 into k plus 1 plus 1 whole square. Let us solve this one because that helps us to later on. Okay, it's a 1 upon 8, it's a 2k plus 3, 2k plus 3 ka whole square. Okay, that you know, that's a 4k ka square plus 9 and that is equal to 12k. So let us solve this one, which is equal to 1 upon 8 into 4k square, 3 square, that's a 9, 3 to the 6 plus 12, so it's a 12k. Ultimately, we have to show this inequality. As you know, we have to take the left hand side, so I am taking the left hand side once again. Okay, so in the left hand side, taking left hand side, that means 1 plus 2 plus 3 plus so and so in the last term, that is called your k, is plus k plus 1. As you know, the sum of these result, sum of these terms is 2. That means what was the concept? The concept is that is called your C. It's a concept is that's a 1 upon 8 into 2k plus 1 whole square. So this we have assumed here. So this plus of k plus 1, this one. Okay, so we assumed that sum of these terms is a lesson of this one. So here it is a lesson 1 upon 8 into 2k plus 1 square plus of k plus 1. The last term, that will be a same. K plus 1, that will be a same. And we have to reach up to here. Okay, so let us solve this one. That's a 1 upon 8 into, it's a 4k ka square plus 1 plus of 4k this, and taking 8 as a LCM, so that's why it becomes a 8k plus of 8. Now you can write like this. Okay, so I'm going to erase this one, so it becomes a like this. Now let us solve this one, which is equal to, I'm going to solve 4k square as it is. See, it's a 4k square as it is. It's a 4k and 8k. 4 plus 8, that is called your, so it's a 12k, and 8 plus 1, that is called your 9 upon 8. Done. And this was the your query. So 4 8k square plus 9 plus of 12k upon 8. So this shows the your inequality. So ultimately I am going to write like this. Okay. So this term can be written as 1 plus 2 plus 3 plus so and so plus of k plus of the last term, that's a k plus 1 is less than, because of this one. No doubt this term is equal to and this term is equal to, but ultimately inequalities are there, so that's why we have to write this inequality. So this is less than 4k square plus of 12k plus 9 upon 8. That's all. I've seen so many times that students makes mistakes at here. Sometimes they write this is again a lesson, but it is not lesson. See, this and this both are equal. Once again, this and this both are equal. So equality sign is here, but some of these terms is a lesson of this one, and plus the term same. So that's why we are using this inequality. That's all. This proved that your now see, this is question number 19 from the same exercise 4.1. In this case, he said that n into n plus 1 into n plus 5 is a multiple of 3, or otherwise you can say it's a division by 3. Okay, so I'm going to solve this one. Once again, let you can suppose this is your polynomial p of n. P of n is equal to n into n plus 1 into n plus 5, because in this question right hand side is not given, so that's why I'm supposing p of n for our convenience. Okay, once again, step number 1, put n is equal to 1. Step number 1, put n is equal to 1. So when n is equal to 1, that means p of 1 is equal to, so what is the p of 1? That's a 1 into 1 plus 1 into 1 plus 5. That is equal to your 2. 1 plus 1, 2. 5 plus 1, that's a 6. Ultimately it's a 12. And 12, you know, that is equal to your multiple of 3. 3 4s are 12. So it's a multiple of 3. So that means your result is 2 for n is equal to 1. So this is step number 1. Now in the step number 2, we assume that this result is true for n is equal to k. That means we assume that p of k means that's a k into k plus 1 into k plus 5 is multiple of 3 is I want to write like this, is multiple of 3. That's all. So this was your concept. Now in the step number 3, we have to prove that this result is for k plus 1. That means this is your k plus 1. I'm going to replace this is k plus 1. This is your k plus 2, and this will be equal to your k plus 6. Okay, and that should be equal to multiple of 3. So this result we have to prove. For this, if we want to prove this one, for this we have to use a step number 2. So we have to reduce the terms k plus 2 and k plus 6, so that it becomes a k plus 5, and this is your k. So we have to manage these terms. I am taking a left hand side. Once again, see it's very carefully. Okay, so I am taking left hand side. That means k plus 1 into k plus 2 and k plus 6. Okay, I want to manage these terms. So you can write like this, k plus 2, because all the terms are under multiplication. So you can write like this, k plus 2 into k plus 1 into k plus 6. No problem, because all the terms are under product. So you can write like this. I want to distribute these terms, split this k plus 2, that's a k and a plus 2. You can write like this. So see what's happened now. I want to multiply this whole term by k and then whole term multiply by 2. So k into k plus 1 and k plus 6. The logic is I want to use this concept. We have to use the step number 2. And plus 2 into k plus 6 and k plus 1 and k plus 6. I like this. But the problem is, this is the term is k into k plus 1, k plus 5. So once again we have to split 6. 6 you know that can be written as a 5 plus 1. So see, k into k plus 1, and this is equal to, now it's a k plus 5 plus 1. You can write like this, 5 plus 1 this, and plus 2 into the term, this will be a same. No problem is with this part, because this is a ultimately multiple of 3. Later on you will see this is a multiple of 3. So no problem with this part. We have to manage only this part. Okay, which is equal to, now you have to multiply these terms by k plus 5 and then 1 into this term. Same concept is here. So it's a k into k plus 1 into k plus 5 plus, we have to multiply these terms by a 1. That means k into k plus 1. When we multiply this whole term by a 5, and then we have to multiply by a 1, plus of 2 into k plus 1 into k plus 6, like this. After this, you see that's a k plus 1 is a common from these two terms, and this is now that concept that is in the step number 2. This is step number 2. That's a k into k plus 1, k plus 5, and you know this is a multiple of 3. and we are seeing in step number second. I am taking k plus 1 as a common from here. See from here k plus of 2 into k plus 6 means 2k plus 12. So it's a k into k plus 1, k plus 5 is as it is, and it is equal to your k plus 1 into it's equal to 2k plus of 6 to the 12. It's a 2k plus 12 and 1k is there, so it's equal to 3k. 3k plus 6 to the 12. This. Ultimately it is a multiple of 3 because if we take 3 as a common, so it's a multiple of 3 and this is again a multiple of 3. So it is a multiple of 3 and this is again a multiple of 3. So overall the term is multiple of 3 and that we have to prove. Okay, so that means result is to for n is equal to k plus 1. That's all. So this was your question number